Hello everyone. In this video, I will be talking about system of particles and rotational motion. Now, all bodies in real world are of finite size and made of a system of particles. So for considering motion or such a particles, the system has a whole has to be taken. Extended bodies are considered as rigid bodies to solve many problems associated with it. Ideally, a rigid body is a body with a perfectly definite and unchanging shape. The distance between different pairs of such a body do not change. But in real world situations, we know that a force is able to change the orientation of the particles inside a body. We have neglected this and considered this as a rigid body. Okay. So in this chapter, we will be considering the system of particles as a rigid body. Now we shall see types of motion of a rigid body. This is the first kind of motion that rigid body is capable of, that is translational motion. In this figure, we can see a block sliding along an inclined plane. In this case, all the particles of the block are moving with the same velocity. This is known as the translational motion. Then another type is the rotational motion. In this case, a rolling body is coming down the inclined plane. In this case, the body is rotating about an axis which is passing through the center of this body. That is rotational motion. Then there are certain kind of other motion in which the rotational motion in which the axis also keeps on changing. For example, in the case of a top, the axis keeps on changing its position as opposed to the case in which the axis is fixed. Similarly, when we see the case of a pedestal fan or a table fan, which is rotating, in this there are two types of motion in the case of a table fan. That is, there is a rotational motion of the fan blades as well as the oscillating pivot motion of the direction of the fan. In this case, only a point which is the intersection between the axis of the pivot and the rotation of the blades remains constant. These are more complicated cases and we are not considering it as much in this chapter. Okay. Now we can see the first important concept in this chapter, which is center of mass. That is, the center of mass of a body or a system of particles is defined as a single point at which the whole mass of the body or system is imagined to be concentrated and all the applied forces act at that point. That is the center of mass. Consider a system of n particles of masses m1, m2, etc. to mn whose position vectors are r1, r2, etc. to rn. Then the center of mass of the system is defined as the point having the position vector r and is equal to r is equal to sigma of I is equal to 1 into mi by m, where m is equal to sigma is equal to 1 to n mi for the total mass of the whole system. Now the center of mass of a system of particles moves as if all the mass of the system was concentrated at the center of mass and all the external force were applied at the point. This can be further proved by using these equations. As we have already seen that the center of mass is given by r is equal to sigma E is equal to I based m ri, we will bring m to the left hand side. Then mr is equal to m1r1 plus m2r2 plus mn. Now differentiating on both sides, we get m into dr by dt is equal to m1 dr1 by dt plus m2 into dr2 by dt, etc. to drn by dt. But we know that dr by dt, which is the rate of change of the position, is the velocity. Hence, mv is equal to m1v1 plus m2v2, etc. mnv. Now we will again differentiate both sides. That is m dv by dt is equal to m1 dv1 by dt plus dv2 by dt plus mn dvn by dt. That is dv by dt, which is the differential of velocity or the rate of change of velocity, which is acceleration. Hence, ma is equal to m1a1 plus m2a2 plus mn an. But by second law of motion, we know that ma is equal to force. Hence, we can write m1a1 is equal to f1, m2a2 is equal to f2, etc. That is, ma is equal to f1 plus f2 plus etc. fn. But as given by Newton's third law of motion, the internal forces cancel out each other. Hence, the total force acting on the body is only the external force. So we can see that ma is equal to F external. Now linear momentum of system of particles. The total momentum of a system of particles is equal to product of the total mass of the system and the velocity of its center of mass. When the total external force acting on a system of particles is zero, the total linear momentum of the system is constant. This is the law of conservation of total linear momentum of a system of particles. That is, P is equal to mv. Now differentiating, we get dp by dt is equal to m dv by dt. That is, m into a is equal to f external. And when f external is equal to 0, we get dp by dt is equal to 0. It proves that P, which is momentum, will be a constant since the differential of a constant is always 0. So this is the end of this video. In this video, I have just given an introduction to the concept of system of particles and the linear momentum and center of mass. If you have got any doubt in any of the topics discussed in this video, please comment in the section below this video. Thank you.